Hi, this YouTube video is to explain how to use a script written for the software FIJI. I take for granted that you have already installed this FIJI software, which is a ImageJ software written in Java, which is available on Windows, Mac OS, and Linux. When FIJI is installed, in order to use this script, which will help you to determine the denominator for better assessment of CPS in PDL1 assessment, you need to install two additional plugins, which are a plugin related to neural network utilized by the plugin StarDist, which permits close to perfect nuclear segmentation. So you need to click under Help. You need to click under Update. And then the software will check if you are up to date, which is the case here. Then you need to click on Manage Update Sites. And you will need to click on CSB Deep, which is a neural network plugin. So this is already checked for this installation. When this is checked, you need to also check another one, which is StarDist itself, here. So you click on this and you close. Normally you should be capable to click on Apply Changes, which is not possible here because nothing was modified. And then eventually you'll close, and these two plugins will be added. When this will be done, you need to add the third script, which was written specifically for CPS PDL1 assessment. And in order to do that, you need to localize where you save this script. In this example, this script is saved in a peculiar directory. It will be totally different for your installation. Here we look under Share, and you see here this is the CPS Denominator.IJM, which means ImageJ macro. So you write, there are many ways to do that, but a simple way is to right click on your mouse and copy this piece of software. And then you go under the FIJI directory, which in this case here is located here on my desktop. So I click on this. I will go under FIJI, click on FIJI.app. I click on macros, and then I click on toolsets. And you can see it's already installed, but I will paste it for real. And I will copy and replace. Here we go. So you will need to also to shut down FIJI and restart it to take advantage of the new script. So we will open an image with FIJI, and one simple way is to drag and drop like this. This picture was taken by a specific camera. You will need to get precise measurement of the horizontal and vertical dimension of your image. And eventually you will also need to know the dimension of your, for instance, 20x diameter microscopic field. When you get these data, you'll need to enter them under, so first of all, you need to activate the script I was talking about. So you click here, and you can see more tools menu, and you see CPS Denominator. You click on this, and we have these new buttons that I will explain shortly. If you click first on setting menus, you can define the dimensions I was referring to. So image horizontal dimension in millimeter, image vertical dimension in millimeter, microscopic field diameter, the objective, and you click on OK. These data will be saved permanently, but they can be modified if needed. So click on this. Now we have the picture. The first thing we need to do is to do some nuclear segmentation. We'll click on this button here. And there is a warning that can eventually be removed, but this is just to remind you that the StarDisk plugin is not the fastest. It's very accurate, but not the fastest. So we'll click OK to acknowledge that this may take some time. It will take approximately 15 to 20 seconds. The script is capable to automatically save the segmentation. So the next time, if needed, you won't need to re-segment if you reopen the software a bit later on. You can automatically get this segmentation. As I said, it's not fast, but it's very precise. So we have this nuclear segmentation, and the next step we'll do is some sort of classification based on the area of the nuclei and the circularity of the nuclei. What I mean by that is the stromal cells, for instance, are frequently elongated, which means their circularity is low compared to tumoral cells, which might be higher. And also the size will play a role in this classification. So we'll click on the scatter plot here, and you'll see the scatter plot of all the nuclei according to the circularity along the y-axis and the area along the x-axis. And we have a threshold for area and a threshold for circularity, which roughly gives us a relatively good classification between the red nuclei, tumoral cells, and the green nuclei, either stromal or some immune cells. These thresholds can be easily modified by clicking on this icon here. And we could, for instance, put 450. You see the x-axis here from 0 to 3000. So let's put 450, and let's put 0.75 for the circularity. And here we go. So we have this, and what this scatter plot also gives us is the data you're looking for, which is the number of nuclei in the image. We have 802 nuclei, red nuclei, which are tumors, and we have 1031 other either stromal cells or lymphocytes. You have here an icon which permits to remove the overlay back and forth like that, and you can verify what type of work was accomplished, so you can fine-tune eventually your work. So as I said, if I get rid of this image here and I reopen it, the moment I will click on segmentation, instantly we have the same segmentation because that was saved. And that was saved at a specific location in the FIJI directory. If I open this, you can see ROIS, which stands for Region of Interest, CPS. If I open this, you can see this file contains all the segmentation of this image. So over time, you can have many of them if you open different images. And at one point, you may desire to remove all of them. So one icon here is to erase all the ROI. if I click on this, we will be asked, are you sure you want to erase this? Let's say OK. And you'll see the file has disappeared. So which means the next time I will click on segmentation, there is no saved ROI, so the process will restart. We can take another example here. That will take too much time. That will take approximately 1 minute, so we won't do it. So basically, this is it. And this may help you to assess CPS, because knowing the number of tumoral cells, let's say here, the expected number of tumoral cells at 20x is close to 2000. So you would expect 20 events of positivity for PDL1, either membrane staining for the tumoral cells or immune cells, either lymphocyte or macrophages, but not the stromal cells. So I thought it's quite difficult to visually assess the number of cells, so this tool might help you to figure out the number of tumoral cells for the denominator.